Real invisibility may be closer than you think.
I'm invisible?
To make something invisible, we usually think about seeing through the object. But this is quite hard. What's more feasible is to see around it. Thanks to some research into nanomaterials, this is starting to look achievable. Light changing direction is something we see all the time. It's how rainbows work, for example. Let's think specifically about how light bends going from one material into another. You might know this is called refraction, and it's described by Snell's law. This is what the equation looks like. The value n, known as the refractive index, determines how much the light bends inside the material. The bigger the value, the more the light bends away from the surface. We used to think n has to be greater than 0, but what would a negative value look like? As you can see, the light ray appears to be bent backwards. We call this negative refraction. Using this, we can force light to take any path around the object, creating a real invisibility cloak. Another cool application is superlenses, which can be flat but see much smaller structures than any standard lens. The problem is, achieving this can prove expensive. Here is Dr. Macedo of the University of Glasgow to talk about a potential alternative.
People used to think that negative refraction was a property that you couldn't find in nature, so you had to actually build the metamaterial in order to find it. But at the University of Glasgow, we are studying natural materials where you can find negative refraction. So this is because if you shine light, the atomic structure will vibrate differently in different directions, and the combination of these vibrations can generate negative refraction.
Photonics is an active area of research at the University of Glasgow. Google PIADS to find out more.